Hello and welcome. You should be on page 32 of your pre-algebra quarter 3 notebook. We are going to work on the area of complex figures in this video. As a reminder, the area is a measure of the space inside of a figure. So we're looking for the space inside. When we are working with complex figures, we're working with more than one shape all put together. And you want to break that complex figure into smaller shapes, find the area of those smaller shapes, and you may add or subtract to find the final area. So let's take a look at question number 1. First, what shapes do I see? Well, I see a triangle and I see a rectangle. So I see two different shapes. And I'm thinking that I'm going to have to add them because I'm looking for this and that together. So this seems like an adding situation. Well, I can go look in the front of my pre-algebra notebook to get a formula that the area of a triangle is 1/2 times the base times the height, and the area of a rectangle is the length times the width. Well, in order to fill out those formulas, I need to know what the base, the height, the length, and the width are. So let's look at my shapes. Well, let's look at the rectangle first because I can fairly clearly see what I've got. I've got a length of 6 feet and a width of 3 feet. When I look at my triangle, it's a little bit harder. First of all, I have 6 feet here, and in the rectangle, that means this is also 6 feet. Now, if I look at this dotted line, it is perpendicular to this line. So that helps me identify this is the base and that is the height. So I have a base of 6 feet. Got the wrong one. And perpendicular from the base is my height at 4 feet. So now it's a matter of substituting into the formula. I have area equals 1/2 times 6 times 4, and that will equal 12. With my rectangle, my area is 6 times 3, and that equals 18. Now remember, I want to find the total, both of these areas, the triangle and the rectangle together. So if I add 12 plus 18, I will get my final area of 30 feet squared. Okay, let's take a look at number 2. And, well, I see rectangles. And I'm going to try to make this as simple as possible in terms of my measurement. And I see this line here and this line here can break off to form this rectangle. So I have rectangle number 1. And I know the area is going to equal length times width. You know, I like to use different colors here. So area equals length times width. And I'm going to have my length equal 8 meters and my width equal 2 meters. So I got my first rectangle. And this makes it really handy because my second rectangle has very clear measurements. Area is the same thing. And I have a length of 15 meters and a width of 3 meters. Just remember with rectangles, which is the width and which is the length doesn't really matter. Now, I'm going to want this rectangle and that rectangle together. So this is a situation where I will be adding the areas. Alrighty, area equals 8 times 2, that's 16. Area equals 15 times 3, length times width, and 15 times 3 is 45. I am adding, so I'm looking for 16 plus 45. And this will give me my final answer. Area equals 61, and I need to label it as a unit squared, and it's meters squared in this case. Okay, let's look at this next one, which seems maybe like two shapes because I only have 2 lines. I've got this triangle, but this is 2 different shapes if you really look closely at it. I can clearly see my triangle, right? And I can see kind of the beginnings of what looks like a rectangle. But here at the end, I've got a third shape, and that is a half a circle. So I've got three distinct shapes here. I have a half circle, I've got a rectangle, and I've got a triangle. So I have to find the area of all three of these shapes, and it looks like I want them all together, so I will be adding those shapes together. Well, I'm going to have to figure out my formulas. Happily, I've been using the rectangle formula a lot. That's length times width. And the triangle is right above. So that's 1/2 base times height. Let's try to figure out these first. Well, I know that my length of my rectangle is 10 meters. And I know that here is 6, so this must also be 6, and this must also be 6 meters. So my width is 6 meters. With my triangle, I have this measurement here, 3.5, which is perpendicular to this measurement, which is going to be my base, 6 meters. And the height perpendicular from is 3.5 meters. I can figure out these areas by just filling in my formulas. I'm going to give myself some space here. Here, the area will be 1/2 times 6 times 3.5. And I will put that into my calculator, and I will get an area of, let me just do that again. I got 1/2 times 6 times 3.5. And I get 10.5 meters squared for the area of that triangle. Now, when I look here, I know that I want the area to be 10 times 6. And so my area of my rectangle will be 60 meters squared. But we need to find the circle, and that's not a formula we've used so far on this particular sheet. Now, if I go back and look at the area of a circle, I will find out that the area is pi times the radius squared. Now, if I look at this circle, I know this measurement right across the center is 6 meters. That's the diameter. The diameter is 6 meters. Well, I might also remember that the radius is the diameter divided by 2. So if I divide 6 divided by 2, I will get 3, and there's my radius, 3 meters. And we will use 3.14 for pi. Now I'm ready to calculate this and fill in this formula. So the area is going to equal 3.14 times the radius squared. Order of operations does tell me I must square it. So I get 3.14 times 3 squared, which is 9. And that equals 28.26 meters squared. But hold on, that's the full circle. I only want half the circle. So I need to divide 28.26 divided by 2. And that will give me the area I'm looking for, which is 14.13 meters squared. Phew! So now I've got 1, 2, 3 different areas. So I'm going to add 60 plus 10.5 plus 14.13. And I will get my final area of 10.5 plus 14.13 plus 60 of 84.63 meters squared. Okie dokie, last one in this video is number 4, and you're going to notice that it looks completely different than the other problems. All of these problems, I had the triangle, the rectangle, 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 half a circle, rectangle, and they all seem to be the same in terms of their coloring. This has a shaded region, and they just want me to find the area of this shaded region. And it looks like it could be as simple as finding a rectangle, right? But I have a circle cut out, and this circle is not shaded. Because I want part of this rectangle area to be out, this is going to be a situation where I will be subtracting. So this is an example of when I subtract using my area. So what shapes do I have? I clearly have another rectangle. And of course, area equals length times width. And I can see that the length is 26 inches and the width is 12 inches. So my area will equal 26 times 12, which is 312 inches square. Okay, no problem with the rectangle. Let's take a look at the circle now. In our last problem, we discovered that the area of a circle is pi times r squared. Well, I need the radius. So I've got to think, well, I don't have anything here, but I do know this measurement all the way down, so I could put it all the way down the center, is 12 inches, right? So my diameter equals 12 inches. And I know if I divide 12 by 2, the diameter divided by 2, I will get the radius of 6 inches. Now I have what I need. Well, of course, I also know that I'm going to use 3.14 as pi, and I can calculate the area of this circle. So area equals 3.14 times 6 squared. Going to square 6 first, get 3.14 times 36, and that is going to equal 113.04. So remember, I'm subtracting now. So I need to look at 312 minus this unshaded portion to get my final area. The area will equal 198.96 inches squared, and that represents the shaded region of that complex figure. That's all for this video. Thanks so much for listening. Bye.